Yeah, okay, Assalamu alaikum everyone. So today it is the continuation of our discussion on structs. We'll basically be talking about uh, different types of operators can be used with structs. We'll talk about the assignment, statement, relational operators, and we'll also talk about arrays in structs and then structs as arrays. Nested structures, setter and getter functions, constructors again, and we'll also talk about default constructors and parameterized constructors, and finally we'll talk about access modifiers in structures that modify uh, the scope of variables that have been defined under structs. And as in the previous videos, I'll basically be implementing and showing you some of the some of the programming practices that are used in structs. So before we move on to that part, where some programs will be shown to you, and we'll run them with various operators and see that how the structs actually behave. I'll just revise some of the stuff that we did in our earlier lecture, and that's about structs. So primarily, structs are used for record keeping, and especially if the records are of different types. Data types consist of different data types. For example, student records consist of the name of the students, student ID, GPA, courses that a student takes, the university in which a student actually studies, the department in which that student is actually taking those courses, and what are the student grades, or what are the grades of that student. Now you can see that all of these different parameters that are associated, or attributes that are associated to a student, all of these are of different types. Student name could be string, is string. Student ID could be a mixture of strings and numbers, or it could simply be a number, integers. GPA could be double or float. Similarly, the courses taken, if it is the course code, then it's a mix of the the department acronym and a number that is associated with the course, and grades obviously are string types. Okay, so structs are user-defined data types that combine all these different data types together, which are default data types that are present, or built-in data types that are present in C++. So, for example, here we can define a struct student type that may include student name, student ID, GPA, courses taken, and course grades. And we can group all these different attributes as a single user defined data type. So struct is primarily a data type that is defined by a user, and that actually combines different other data types together that are built-in data types. Okay, so a collection of fixed number of components in which the components are accessed by name, and the components may be of different type. And here, when we say type, it means that we are talking about different data types. And this is an example of that struct which we just described, that is a student type. And here you can see that we have defined few variables here inside this struct student type. The name of the struct is student type, right? And then we have, let's say, various variables defined within that. First name of the student, the last name of the student. So the type followed by the name of the variable. Then you have a character, course, grade. Then you have integer as test scores, integers as programming score, and then GPS double. Now outside these parentheses, here we have defined an instance of this data type, which is struct, yeah, which is student type. So student type is the name of this new data type that combines all these different attributes together. Okay, so the name of this data type, the name that is given to this data type is student type. Okay, which is here, right? And one instance of this is, let's say, temp student, right? Temp student is one instance of that. And as you know, there could be number of students here that are present in a university or in a department. Therefore, each of the student will have all these different attributes or variables that are associated with it. Okay, so in order to access a record of a student, we can define an instance of this data type, student type. Okay, and then within this instance we can add the some values of a particular student, right? Okay, so let me just show you an example again, and I'll take you the to the IDE in order to represent that what how these structs can be represented. Okay, and okay, so I'll just paste a struct here. So this is the struct that we defined, student type, that is the name of the struct, followed by these attributes that we have got here, or variables that are part of this struct, or part of this record. And then if and then we have the instances of these. So here we have defined two students, student 1 and student 2. Student 1 would have its first name, last name, course grade, test scores, GPA, programming score assigned to it. We haven't really done that here, but we can do it later on. And student 2 would also have its own values for these attributes that we have got. So this struct is defining a student type, its attributes, and two instances of student types. Okay, so this is like one way of defining a student type. There is, you can also write it in this way. I mean, if you want to define uh, an instance of student type, and you can write this in your main program as well. So student type is the name of the struct that is representing all these different attributes. And let's suppose I want to represent a third student, so I can write down student 3 here, and that's it. That's primarily representing a third instance of student type. Now all of these students, student 1, student 2, student 3, all of these will have all these attributes that are highlighted, or all these variables that are highlighted. ठीक है जी? Okay, so let's just extend our program a little bit and assign these values. So if I want to assign the values for, let's say, student 1, inside my main program I can write down uh, statements using the dot notation as shown in line number 23 to 28. I can assign the values for the student instance, student 1. ठीक है, और student 1 क्या है? This is an instance of student type that has first name, last name, test scores, programming scores, GPA, and I can assign these values using the dot notation, जैसे पिछले लेक्चर में हमने देखा था. तो dot notation को use करते हुए I've assigned these values to this. So I can use dot notations as we have discussed earlier. You can use pointers also, right, in order to assign these values. And if you use pointers, then instead of the dot notation you'll have to use the arrow notation. ठीक है, और उसका सिंटेक्स जो था वो लास्ट टाइम वी हैव डिस्कस्ड दैट. सो आइदर यू यूज द डॉट म्यूटेशन और यू यूज द pointer mutation in order to assign these values. So this is the information that we have given, or that we have assigned to student 1. Similarly, we can assign all these variables values for student 2 also. But this program is simply representing the values assigned for student 1. Okay. Now, let's just do a simple addition to this program, and that is the use of assignment statement. So we have got two struct types. One is instances of student type. One is student 1 and the other one is student 2. And line number 32 is representing an assignment statement between the two. So what is this assignment statement is expected to do? This assignment statement is expected to copy the contents of student 1 instance into student 2 इंस्टेंस. सो दैट मीन्स कि स्टूडेंट 1 का जो फर्स्ट नेम है वही स्टूडेंट 2 का फर्स्ट नेम बन जाएगा, और स्टूडेंट 1 का जो लास्ट नेम है वही स्टूडेंट 2 का लास्ट नेम बन जाएगा. सो दिस इज एक्सपेक्टेड टू डू अ कॉपिंग ऑपरेशन. Okay, so let's just run this program and see whether this works or not. Okay, so if you run this program, you will find that okay, this works. So student 2 का first name और last name जो है that has been taken from student 1, and that has been copied to student 2. So assignment statements actually work in case of structs. So student 1 and student 2 both are variables of type struct of type student. Let's say student type, the name which we have given to this struct is student type. Okay. So this is the name that we have given to this. So student 1 and student 2 are variables of student type. Okay. Okay. And let's see if, and now because these two values have been that has been assigned, so that means that student 1 and student 2 both of them are representing the same student. Okay, so in that case, if I want to check whether the credentials of student 1 and student 2 are exactly the same, and if they are same, then the end result should be okay, student 1 and student 2 are exactly the same students. So I am talking about the same students here. So in order to check that whether student 1 and student 2 are exactly the same, I can write down a conditional statement of this form, where I am saying that acha, agar student 1 is, and here it's basically the relational operator that we are talking about, or the logical operator that we are talking about. It compares कि क्या student 1 और student 2 same है या नहीं है. Student 1 और student 2 same कब होंगे? जब उनका first name same होगा, last name same होगा, GPA same होगा, all the variables that have been defined by student type, if they are same, तो ये दोनों students जो हैं they'll be exactly the same. So if statement के अंदर I am trying to use this. So relational operator मैं इसको इस्तेमाल करना चाह रहा हूँ यहाँ पे लाइन नंबर 38 के अंदर. एंड दिस इज हाउ यू कैन कंपेयर द टू वेरिएबल्स. सो लेट्स सी कि बिकॉज स्टूडेंट 2 एंड स्टूडेंट 1 आर आल्सो वेरिएबल्स, बट देयर टाइप इज struct student type. ठीक है, so let's just run it. But you have to keep this in mind कि student 1, student 2 both are representing different types of, a combination of different types of variables. ठीक है, they are not representing a single variable type. They are representing a combination of that. So therefore, let me just run this and see whether it works or not. And here you can see that it doesn't compile. ठीक है, it doesn't compile. So that means कि ये जो assignment statement, it gives you an error at this assignment statement line number 38. So this assignment statement will not work for structs or variables of type struct. ठीक है, लेकिन if I just take the first name of the student 2 and compare it with the first name of student 1, and now because I am only talking about first name, and that is not representing a hybrid variable, or that is not representing a combination of different types of variables, तो क्या अब भी ये काम करेगा या नहीं करेगा? So let us just run and see, and you can see that now it actually works. ठीक है? So individual variables that are part of the struct, उनके लिए relational operators will work, but for the struct as a whole, or for the complete record, this type of relational operator will not work. Okay, so you have to keep this thing in mind. Okay. Another very simple thing that you need to know, and that is कि आप variables, I mean functions लिख सकते हैं that are that may or may not be part of the struct that you have defined. यहाँ पे मैंने दो functions लिखे हैं which are written outside the struct definition. ठीक है, so they are independent in their right. लेकिन इनका जो argument है, that argument is primarily a struct. ठीक है, an instance of a struct. ठीक है, struct को as such आप पास नहीं करेंगे, बल्कि instance of that struct पास करेंगे. यहाँ पे इस argument में आप student 1 पास कर सकते हैं, student 2 पास कर सकते हैं, student 3 पास कर सकते हैं. And this is passed by reference, ठीक है, because of this ampersand sign. Similarly ये एक और function है which is void return type print student details. और इसमें भी आप देखें the argument that you have actually passed in this particular function also is of type is of type struct. ठीक है, लेकिन the argument that you have passed is an instance of struct. ठीक है, तो struct type ampersand an instance of that. ठीक है, and in the main program if I want to call this, I can simply write down, let's say read in, and I'll just pass on an instance of struct type. So there are two instances that have been passed. I'll just pass student 1 as an instance. ठीक है, and then I can also say that okay, print student में भी student 1 को मैं print करता हूँ. and just to make things easier यहाँ पे मैं इसको comment out कर देता हूँ for a while. So what should happen is कि अब इसका वो student का course grade जो है वो मैंने explicitly यहाँ पे line number 40 पे लिखा हुआ है, लेकिन then I'm calling a function which is read in, which is read in, takes a struct instance as an input. ठीक है, और then it calculates के टेस्ट स्कोर्स और प्रोग्रामिंग स्कोर्स की एवरेज लेता है, and if that score is greater than equal to 90 तो फिर grade A assign करेगा, if it is greater than equal to 90 between 80 and 90 तो फिर B assign करेगा, and so on and so forth. ठीक है, so here I have actually added the values here कि test scores 75 और 80 है, और इस वक्त जो स्टूडेंट ग्रेड था इससे पहले वो A ग्रेड था, and because I am passing by reference here, you will see कि रीड इन के अंदर जो कोर्स ग्रेड के अंदर जो चेंज आई है, whether that will be reflected in my print or not. And here you can see that grade C has been assigned, ठीक है, to the student. ठीक है, and that is because the course grade has been updated because of the new additions that I've actually done. अच्छा, और अगर मैं इसको पास बाय वैल्यू करूँ तो कंपाइलेशन में कोई प्रॉब्लम नहीं आएगी. इवन इन दिस केस कंपाइलेशन के अंदर कोई प्रॉब्लम नहीं आएगी, लेकिन you just keep an eye on the grade. So it's grade A. So that means that a course grade has been changed, but that has been changed within the scope of this function. Therefore that will not be displayed at all. ठीक है, जो मैंने explicitly line number 40 के ऊपर मैंने display किया हुआ है, that will be displayed in this print statement. ठीक है, because I have passed it by value, not by reference. ठीक है, so you have to be a little careful. Okay, there are few things that we also need to know, and that is कि arithmetic operators जो हैं वो structs के ऊपर जो है ना वो काम उस तरह से नहीं करेंगे. फॉर एग्जाम्पल if I want to add two structs together, दो integers को तो मैं ऐड कर सकता हूँ, but I can't add two structs data types together, struct types together. ठीक है. Assignment statement will work. I've already shown you. Comparison will not work. That means relational operators will not work. पैरामीटर पासिंग जो है वो स्ट्रक्ट में बाय वैल्यू भी हो सकती है और बाय रेफरेंस भी हो सकती है. ठीक है. और फंक्शन रिटर्निंग अ वैल्यू दैट इज आल्सो पॉसिबल कि द रिटर्न टाइप ऑफ अ फंक्शन कुड आल्सो बी अ स्ट्रक्ट. ठीक है. रिटर्न टाइप ऑफ अ फंक्शन कैन नॉट बी एन एरे बट इट कैन बी a struct. So there is some attributes that are associated. So I'll just repeat, and that's also in the slides. You can also go through that. Slide number 8. Arithmetic operators in structs cannot take place. Assignment statement can take place. Input output of structs cannot take place. Comparison between two structs using the relational operators cannot take place. Parameter passing by value and by reference can take place. And the return type of a function could also be a struct. That is possible. Okay, and maybe I'll show you an example for that. But before we move on to that, let me just show you another example here. जिसमें an array has been considered as a member of a struct. ठीक है. So we can make an array struct member or a data member. ठीक है. So data member. So यहाँ पे let's say कि मैंने array size define कर दी. I mean this is a huge number. I can like reduce it to 10, let's say. ठीक है. और यहाँ पे मैंने एक struct define किया, and within this struct you can see that the first variable that has been defined as a data member is an array. So an array can be a data member. ठीक है. An array can be a data member of a struct. ठीक है. जैसे integer could be a data member, float could be a data member, function could be a data function could be a function member. ठीक है. और a member function. इसी तरह से जो है array can be a member of a struct. और यहाँ पे struct जो मैंने define किया है उसका नाम जो है that is list type, and there are two integer variables that are part of it. In fact, one is the variable which is list length, the second one on line 17, and the first one is an array of size, array size, which has been defined as a constant, so that you can't really change this value while executing the program. And this is like a way of initializing this array that is a member of that. Remember, if I want to populate list element or list element or list elem, whatever you call it, अगर मैं इसको populate करना चाह रहा हूँ तो I can use the index, but in order to call this array which has been defined at line number 16, I'll have to use the dot operator. और dot operator किसके दरमियान होगा? An instance of list type. An instance of list type has been defined at line number 22, which is list type followed by int list. So int list is the instance or a variable of type struct. ठीक है. और इस type struct का नाम list type है. So here you can see कि at index 0 I am putting some value, at index 1 I am again putting some value. ठीक है. And so on and so forth, and then I'm just displaying these values. So the main purpose of showing you this program is कि an array could be a data member. ठीक है. array को मैं data member के तौर पे यूज़ कर सकता हूँ और डिक्लेयर कर सकता हूँ in my program. Okay, now what else? Another important thing that we need to know is कि we can define तो अभी हमने क्या किया कि a data member could be part of a struct data type, right? That's perfectly fine. Okay, now let's discuss another aspect, and that is कि क्या मैं मल्टीपल स्ट्रक्ट इंस्टेंसेस को एज एन अरे डिफाइन कर सकता हूँ या नहीं कर सकता. दैट मीन्स कि लेट्स से जैसे मैंने स्टूडेंट्स की बात की, तो देर आर मल्टीपल स्टूडेंट्स दैट यू हैव इन अ यूनिवर्सिटी. ठीक है, and every student has some attributes or some variables associated with them. So one way of defining these students is as we have done in an earlier example, जिसमें हमने क्या किया था, स्टूडेंट वन, स्टूडेंट टू, स्टूडेंट थ्री, ये डिफरेंट इंस्टेंसेस ऑफ स्ट्रक्ट हमने डिफाइन कर दिए. ठीक है, and if there are 100 students, I can declare 100 instances. ठीक है, so is it possible that I can represent these 100 instances of students as an array of structs, as an array of structs. That means कि मैं वो 100 instances को as an array define कर दूँ, and each tuple of that array, each row of that array, or each column of that array, that could represent one instance of struct. ठीक है, that could represent one instance of that struct. Okay, so let me just show you whether this is possible or not. Okay, so let me just show you another program here. Achha ji. So here is a struct that is named as employee type, और ये इसके मुख्तलिफ एट्रीब्यूट्स हैं विच आर पार्ट ऑफ इट. स्ट्रिंग, फर्स्ट नेम, लास्ट नेम, पर्सन आईडी, डिपार्टमेंट आईडी, ईयरली सैलरी, मंथली सैलरी, ईयर टू, date period, and monthly bonus. So these are the different variables that are part of employee type. And in a company you can have multiple employees. और अगर मेरे पास लेट से 100 एम्प्लॉयज़ हैं, 50 एम्प्लॉयज़ हैं या 10 एम्प्लॉयज़ हैं, तो एक तो तरीका ये है कि आई कैन राइट डाउन हेयर लेट्स से एम्प्लॉई 1, comma employee 2, comma employee 3, and so on. I can write down, let's say if there are 50 employees, I can write down 50 entries for emp1, emp2, and employee 1 and employee 2, and so on and so forth. So is it possible that instead of writing down this instances 50 times separately, I can declare an array of instances? Yes, it's absolutely possible, and for that I can use the array notation, and this is how the array notation has been used in this particular case. So employee type is the struct type that I've defined from line 12 to line 21, and then employee has been declared as an array. An employee is a struct variable here. Employee is a struct variable.